make like a small change. But either way, it's mostly going to stay the same as what I have now. So I can show you guys what I've done in the past couple weeks. So first of all, something that I've talked about before is this thing that I've been calling a match mindset. So, okay, just to like set the stage for the problem.
Yeah, I was just going to ask for that. Like, can we start at the outside?
Yeah, I know, right? Like,
this looks like a super dense place to dive in.
Well, so let me try to make it as simple as possible, right? So, I want to have a satisfactory notion of what it means for a receive with multiple listens. So like this, for example, and this, right? Like, what does it mean for these receives with multiple listens to match one another, like in terms of pattern matching, right? And for me, the really difficult part is the fact that the ordering of the binds, it doesn't matter, right? Like the terms are structurally equivalent, even if the binds are in different orders, and that kind of poses an issue in some sense. And so basically, I mean, like, all I'm saying is here is, so regardless of what form you give me, so like here's some particular form for this receive expression, it has 4 binds. Like there's no question, like no matter what order you give me this receive in, it's gonna have the same number of binds. And also, regardless of what order you give me them, I can always index them. Like, you know, this just happened to be the first one that was there, so I call it the 0th one. This was the second one that was there, so I call it, you know, the first one, and so on and so forth. And I just index the binds in whatever order they were presented. And that's, you know,
can I ask
same goes here too. Yeah, what's up?
Do you have like canonical ordering for this listens?
So yes, but in doing some tests, I've found that even given the canonical ordering, it's not enough to test all of like the matching possibilities. And that issue comes up when you have like, you know, concrete channels and like variable channels, because like you have to make a decision like, oh, this concrete channel is going to come first and the variable channel is going to come second. But then you might be trying to match something that has like 2 variable channels, and now it's like, well, you know, which concrete, you know, which variable does the concrete channel match up with, and which one does the variable channel match up with, and things like that. And so I'm thinking of like a more general situation. So it's not like all of these channels are concrete, because of course, if this was like a receive that I've deployed to the tuple space, it should have all concrete channels, right? I can't have any top level free variables, so like all of my channels should be concrete. But I'm trying to do this implementation in the most general way, basically. So from the tests that I've done, even given some like specific ordering, it's not enough to then test all of the possibilities as far as I've seen.
Yeah.
And so basically, okay, so what I have here is like, I have this receive, this is the one that I'm gonna call the candidate receive. And my question is whether or not it matches this one. So this is like the to be matched receive, right? So I have 2 receives with multiple listens. They happen to just be, you know, linear binds in each of them. It doesn't really matter what the type of bind is. But the point being is that this one is the candidate on the left and this one on the right is the to be matched one. But either way, so what I'm going to do is, regardless of the order.
Wait, I have a kind of a silly question. Which one is the pattern? This is about
pattern.
Yeah.
So the right one would be the pattern, the to be matched one. Yeah.
Okay,
so
does
like, yeah, I'm saying
like, does this thing on the left match the pattern on the right?
Yeah, exactly. So this is, I want to see this pattern matched by something, and here's a candidate to potentially match that pattern. So regardless of the ordering of the binds that I'm given, I can index them. And so I have the, you know, the index written above them. And then basically what this function match bind set does, it basically gives you a map. I've been calling them index sets, but effectively it's the same thing as a map. And I tested using a map as opposed to this construction. And for whatever reason, it didn't work the way that I wanted to. So I just went back to this index set construction. So let me explain what's going on here. So the first term, so like the first element in this set, right? So the way that K displays the elements of a set is it basically has this set item wrapper that wraps the element that's in the set. So this is like the first element of the set, and then I have the second element of the set, so on and so forth. And there's 4 elements in the set because there's 4 binds in each one of these receives. So what this match bind set function does is it basically will look at the candidate receive, and it will say, okay, let's just focus on this 0th bind. And then I want to go and look at this to be matched receive and, specifically the binds in there. And then I'm just going to say like, okay, focusing on this 0th bind, which of these binds in the pattern does it match basically? And so that's what this first element in this set is capturing. So it's saying, I'm looking at the 0th bind in the candidate, and in the pattern receive, it's going to match the 0th bind there and the first bind there. Right, so basically what I'm saying is this bind matches this one, and it matches this one. And what I mean by matching a bind is like the channels match, right? So this one's like quoted process variable. I always put this slash in front of a variable so it knows that it's a process variable. And that the binding variables have the same number. So there's like, 1 here, there's 1 here, there's 1 here. And if it's a variable, well, all variables match all variables. But if it's like a concrete term, it'll go into some more structured matching for that concrete term. So like, for example, if this was like a quoted send or something I was expecting to receive on this channel, it would look for a quoted send over here to match with. So claim is this 0th bind here on the candidate side matches the 0th and the first bind here, and it does not match either of these, which I think is pretty clear because, well, they both have concrete channels and also they both have 2 things that they're listening for. So this element in this match bind set is telling me that this bind matches, the 0 and the first one over here. And then I do the same thing for all of these binds now. Like this first one, I'll ask the same question, like what bind the pattern receive does it match? And according to the matches, the second and the third, and you can check that, right? So like the channels are the same number of binding variables, and they're all just variables, either name variables or quoted process variables. And then
can I ask you how can first in the process can be matched with second? Oh yeah, with the second. Oh yeah. CD.
Yes.
CD. Okay.
Yeah.
Not B. CD.
Yep.
Yeah. Okay.
Two binding variables there and 2 there, and they're just name variables in both cases.
So how can it match with the third one though? Where so it's just you're checking the number, but you're not actually checking.
So I'm checking the number, and the weird thing is like having a notion of variables for names and a notion of variables for processes. There has to be some relation between them, and the relation that I'm using, because this is the notion that's used for our node and for Erlang, is if you have just like a purely quoted process variable, remember anytime you see an identifier with a slash in front of it, it means a process variable. So any quoted process variable is essentially the same thing as a name variable, and vice versa. Any like evaluated name variable is essentially just the same thing as a process variable. So it matches the structure up to that like kind of identification of like quoted process variable with name variable and evaluated name variable with process variable. So you were saying it checks the number of variables. That's one thing that it checks. So it checks the channel, if it matches the channel in the bind over here. It also checks the number, and then it also checks like, sequentially if those binding variables match, or binding patterns, or whatever you want to call them.
Yeah, this CD is not a tuple.
It's not a tuple. Yeah, exactly.
Argument to
Right. Yeah. So this bind is saying like listening on the channel at 0. I want two names, and I'll call the first one C and the second one B.
It's like receiving 2 things on channel 0.
Yeah. Exactly. Yep.
Okay.
Yeah. and then this is, effectively the same thing, except we're not binding the names to two name variables. I mean, we're binding one of those names to a quoted process variable. So we're binding like the underlying process to this process variable. Yeah, go ahead.
I mean, you're accepting names F on the third pattern. And
yes.
this will match with C.
This will match with.
I'm looking at the first process and you have BC received from zero name.
Yeah.
And how can you match this with the third pattern?
With this one?
No, with the third.
With this one.
Yeah.
Oh yeah.
F,
so. Mm-hmm.
F is a name and C is a process, or?
Yeah, so it's a quoted process variable.
And you can match it with pattern, with the name pattern.
Yeah. Yeah, because any name pattern is just going to be a quoted process pattern.
Oh, so you're saying you will do the conversion if it is necessary to convert from names to process or to process to names, right?
Yeah, and the important part is really like, what does that variable represent? Like the fact that it's a quoted process variable means it's just as good as a name variable, except the binding works differently. I bind the underlying process as opposed to the entire name itself.
Okay.
That makes sense.
Yeah. It's something like syntactic sugar, just.
Yeah, it's syntactic sugar for like pattern matching, basically.
That it does the convert.
Oh, sorry.
That's what I like to hear.
Yeah, that sounded like a revelation.
I was just, it's just that you want to F to be the process, because later you will use F as a process and not as a name.
Yeah. And so like this is a slightly misleading example, right? Both of the continuations are nil anyways. It doesn't matter what I call any of these variables because none of them truly bind to anything because my continuation is null, right? So it's like it's useless from that perspective. But like in general, that's the situation.
Yeah.
And so this particular example, a weird thing happens, and that comes up in this third term in this match bind set that we're looking at. And so basically when I go to match this second, the bind with index 2 in the process side with any of the binds in the pattern side, it doesn't match any of them. And basically the point is because it has a variable name and it's listening for two pieces of information. And so like any of the binds with variable names are only listening for one piece of information. And both of these have concrete names, so I'm not going to be able to match a concrete name with a variable name, basically, because this name could essentially be anything. But here I'm saying very specifically, like it would need to be 0 to match with this one, and it would need to be 0 to match with this one. So it's a no-go for this bind, basically. And so I get this slightly specialized element in my match bind set, which is basically telling me that this, bind with index 2 on the process side doesn't match anything on the pattern side. And so in terms of like going through all of like the checking of like conditions for, potential matchings, there's no possible way for this receive to match this one, because of the fact that one of its binds doesn't match any of the other binds in the pattern, if that makes sense.
Is it make sense to, so you cannot match it because X can be any process, right?
Yeah, right.
But in one instance, X can be 0 process.
Yes, absolutely.
So in that case, you can find a match.
in that case, you could find a match. But yeah, so I guess what I'm saying is for this variable to match with a concrete value, I would already need to know that this variable has that concrete value. Otherwise, it can't possibly match. I don't know. Does that make sense?
Yeah. Do you have situation in which you don't know the exact value of x? So it makes sense. It makes sense to ask. You don't want to have three variables.
Yeah. Well, right. So what I was saying is, so something like this is never going to appear in like, I was sent this thing and I was waiting for this particular pattern, and I want to see if they match. This is never going to be something that you're checking against a pattern that you want to match. But for more general purposes, I do want to know if some structure like this matches a structure like this. So this is a little bit more general example than something that would actually come up in like matching some, data that you've received with a particular pattern.
So in a sense, this means that you are comparing patterns, because X
Yes.
is really making this left side as a pattern, right?
Right. Yeah. Yeah. So in general, yeah, I'm looking at patterns matching patterns.
Yeah, Isaac, didn't you had some interesting concept a little while ago about like you can say that a pattern is like more or less restrictive. Wait, how did that go? Like processes were just patterns that were like really restrictive patterns, and then you could say like if A matches B, like if pattern A matches pattern B, then that means like A is less than or equal to B, and then if you can say it the other way around, then that means you're structurally equivalent or something.
Yeah, exactly. Yeah, I mean that's exactly it. So that's using so not this like matched bind set. This is like a very specialized thing for received with multiple listens. But the construct that this is kind of building on is just like the matching filter essentially, and it's just going to say like give me a pattern on the left, give me a pattern on the right, and I'll say true or false whether or not they match. And that's kind of like, is the one on the left kind of like included, like in terms of type inclusion, included in the pattern on the right? And if that's the case, then okay, it matches. But if we have both ways around, then I think that's the same thing as structurally equivalent, and on the pattern level or whatever.
You can calculate Hamming distance between these processes, right?
What is Hamming distance?
Yeah, what do you mean Hamming distance for the processes?
I mean, what is the amount of error between patterns? Because these sets that you are creating is somehow like error correction that you are building, and if there is no error, the processes are the same. The patterns are the same. Right?
Yeah, it's you'll see it's a little bit different than that. I think this situation is a little more complicated in the sense that this particular example that we're looking at is not complicated in the sense that I don't need to go any further than looking at this match bind set, because I already know they don't match just from the fact that this, bind with index 2 on the process side didn't match with any bind on the pattern side. So like automatically these guys are out of the running for matching one another. But that's not always the case, right? So like, of course, I could give you an example. Like if I were to change this to a 0, basically, like that would no longer be the case. And so now the question is like, well, do they still match one another?
Yeah.
And so, I mean, I have examples like that, but it's essentially the same idea, like, index the binds and then go through each one, seeing like what all binds on the pattern side match this one, et cetera, for each of the binds on the process side. But point being is once I generate this match bind set, this basically tells me like all of the possible rearrangements that could potentially result in a match for these, multi-receives. And so then the question is like, well, okay, that's great that I now have like some sort of way to think about all of these possibilities, but how do I actually put that to use and make it like, tell me like a yes or a no, definitively these match or they don't. So the next step after generating this matched bind set, if that's, more or less clear how that works, I go to this thing that I call match bind maps. So it's like basically just taking the match bind set. And so unfortunately, these aren't the exact same examples, but hopefully that's okay and you'll forgive me for that. So basically what I'm going to do is say there are two possibilities coming from the fact that 0 could match with 0 or 0 could match with 1. And then here there's another two possibilities coming from 1 could match with 2 or 1 could match with 3. Here there were no possibilities, so like I don't even go to this next step, but if there were, then I could, count up the possibilities from that. And then essentially like another two possibilities here, like 3 could go with 0 or 3 could go with 1. The thing that you want to avoid is saying simultaneously that 0 matches with 0 and 3 matches with 0, right? Because it's no good if I'm saying my matching goes through because this bind and this bind or whatever both matched to this one, because we know in reality that's not the way things should work. Like I should have unique matching or distinct matching amongst my binds. So that's one thing that this match bind maps actually checks when it's producing all of these different maps. So what it's going to do is take something like a match bind set. So I have an example, just some random example of like, something of the form of that match bind set. And so maybe I can split this up and make it a little more legible. So this one's got, 3 binds basically. And so we were saying like the 0th bind on the process side could match with basically any of the binds on the pattern side. The first one could match with any of them, and the second one can only match with the 0th one. And then what I'm going to do is from this match bind set that I have here, I'll generate what I'm calling the match bind maps, which is essentially just turning this match bind set into all of the individual like possible arrangements for all of these matching binds. And so like, for example, this one actually results in 2 possible like matchings of my binds. And so they're going to go like 0, well, it could have matched with 0, 1, or 2, but keep in mind that the only way things are going to match is if 2 matches up with 0. So that kind of forces your hand on the 0 on the first one. So either way, really the only 2 options for this guy are 1 or 2 for like everything to go through the way it should. And so one of the maps that I get is like 0 goes to 1, 1 goes to 2, and 2 goes to 0. And why did I have to say 1 goes to 2 after I said 0 goes to 1? Well, because 1 could go to 0, but 0 was already taken by this guy. Okay, 1 was taken by the first guy, so 2 had to be the option for this one. Right, so that's why I'm getting this particular, like once I choose 1 being the bind that I want on the pattern side that I want the 0th bind on the process side to match up with, my hand is forced for this particular one. And then basically the same kind of construction, but now using a different value for this key of 0. Right, so the other option for the 0th bind on the process side was to match up with the second bind on the pattern side, right? It could be 0, 1, or 2. And in this case, I'm just choosing 2 because, well, I already chose 1. I know how that works out. But in the case that I choose 2 for the 0th bind, then I have to choose 1 for the first bind, and so that's where I got that value. And like I was saying from the beginning, 2 has to go to 0 because that's the only possibility for matching of those binds. Any questions about how this match binds maps is working? So right, like I'm saying, we take this possibility, this match bind sets like all the possible configurations, and now I want to generate like individual maps that correspond to each one of those matching configurations.
Yeah, that makes sense to me.
Yeah.
When you're doing it, out of curiosity, are you ordering by sets that have fewer items in order to first fulfill them? Like, would you order here, would 2 come first, you fulfill that one, and then the other ones later?
Let's see. No, I don't think that factors into it at all. Basically, all I'm trying to do is make sure that I don't repeat any values as I'm bringing in these like key value pairs into the maps that I'm building.
Yeah. I mean, it all would lead to the same way. I'm just interested in how you implemented the
It's
function.
probably a really slow implementation because like I'm trying to get the ideas down first, and then like maybe I can come back and optimize them later if there's ever an opportunity to do that. But yeah, so I'm not like checking like, okay, this one's already determined. Like, let's go ahead and populate all of the maps with that key value pair, and then just like fill out the rest or anything like that. What it's doing is basically saying like, okay, well, if 0 goes with 0, well, that's fine. Then I have, some options down here, but then, oh, wow, we get some issues when I try to map 0 to 2 because now I have, values that are not distinct anymore. So I go ahead and just delete that one. So it's doing extra work that it doesn't need to. So that's probably a good optimization. Like just go from the smallest set and like build up from there maybe.
Yeah, because I mean, I don't know how big these eventually get. As long as they're always small, it's probably fine. But this is a very expensive algorithm.
Oh yeah, it's going to be very expensive because it's like constant like traversing over all of these different possibilities, and then I mean, even once we get down to the level of like, okay, here are all of the possible like mappings that kind of encode the different arrangements of these binds. It's like now I have to do all of these different substitutions like according to these binds, and I have no preferred order to do any of these, so I just go from left to right basically. I mean, I don't know a better way to do it. But yeah, definitely like optimizing speed is not my focus right now. It's just like getting the idea correct, I guess. Yeah, so that's the first 2 steps, right? Like first you like match all of these binds together, and you get this match bind set, and then you go ahead and create all of these this like string of not string but like list. I separate it by a semicolon. Like the particular terminal that's used doesn't really matter, but that's just how I have it right now. But now, so basically, if it's passed up to this point, right, it has all of these different maps to check, and then like the question is like, well, what are these maps about? And so, I mean, we can go back to the example was basically, I want to take something like this, and then I'm saying like, oh, well, this could be matching up with the 0th one, and okay, it's matched up with the 0th one. But I'm basically saying now that I have like a particular binding, and that these binding variables are playing similar roles in the 2 continuations. So like the way that I'm thinking about it is like, so this bind had a variable a that I was listening to. It's like a name variable. So this a here in the first received continuation, so in this thing, which of course doesn't even call the variable a, so okay, whatever, maybe this is a bad example. But this variable a will play the same role in this continuation as this variable a will play in this continuation if I'm going off of the matching up of the 0th bind with the 0th bind, if that makes sense. Right, so like whatever free variables or bindings, anything from the name has no bearing on the continuation. It's only this binding variable. So either way, this a is playing the same role in this first continuation as this a is playing in this continuation. So that's kind of where we're at right now. And just to show you like an example of how I build, this kind of like, list of maps from something like this. I'll build individual like key value pairs, and then I have this construction called combine maps that basically just glues them all together and like make sure that I'm not repeating any values in them. So like it would take you know, something like this, which is basically like 3 possibilities for the 0th line. It could either match with the 0th, with the first, or with the second. So just looking at something like this first element in this set, it'll create that map, like 0 maps to 0. Oh, I have another map, 0 maps to 1. Oh, I have another map, 0 maps to 2. And then it will also take, you know, so this is like kind of the first step in this construction, is then I'll look at the, you know, first bind there, which could map to 0, 1, or 2 as well, right? Like looking at this element, and you know, 1 can map with 0, with 1, or with 2, and so that's why I have this particular map that I have here. And then what I'll do is just go ahead and do this combine maps function with, you know, these like 2 sequences of 3 maps. And so I'm basically like trying to add each of these key value pairs from each one of these maps over to each one of these in such a way that the values never repeat themselves. So like 0 and 0 can't possibly get a 1 to 0. So the only 2 possibilities would be the 1 to 1 or the 1 to 2. So it's just showing how that works. So it's literally just building from like the 0th element through the, well, in this case, the second element. Yeah, in a way that's not great, but does the job, I guess. And so after that, we have all of these maps now, right? Well, in this case, 2. I have 2 maps. And so what I want to do is take these maps, and they're going to dictate like what roles the variables play, and like, you know, how the bindings actually work in the continuations. So
Can I ask you before?
Yeah, absolutely.
So I'm just wondering, can you do this in one step or in one round?
Yeah, I'm sure you can.
Can you go to the first? I'm just thinking that if you start, you are trying all the combinations, but when you find out that you have a match with, so you have the first line, the first set, and you know it's 0 is matched with 0 and 0 is matched with 1.
Yeah.
So you can, when you start the second, comparing the second, the first index.
Yeah.
Can you immediately skip something that you already find that is taken from the previous step? So you will not find all of the combinations. You will have to do it again with different choice for the first. But maybe you don't have to explore all of these combinations. You can maybe, in a sense, you will have like resources to spend. When you
Yeah,
match
like,
the bind, you will. Yep.
I was just gonna say, so you're building the maps as you go, and
Yeah.
you stop each time you realize the path doesn't work. So like in the first case, you would assign 0 to 0, and then 2 to 1, nothing to 2, and then you'd realize, oh wait, I thought 3 could only be assigned 0. Is this a different?
Yeah, no, I think that's right. I think you're onto something. So like in this particular case, when you get down to that 3rd line, then like that's the end of the story, regardless. But like if this were one where there were a possibility, then start just like Jay said, like 0 to 0, 1 to 2, 2 to whatever it matches with, and then like if you get to 3, you're stuck. Then okay, go back 1 level up the stack and try like the next possibility for 2, and if you get stuck, then go back up another level.
Yeah.
I wonder if that's like a depth first search.
I'm not sure what the trade-offs are in terms of performance. So I will say, like, the reason that I'm implementing it the way that I'm currently implementing it is because these are the different levels of my understanding of how to do this, and then I just implemented each one of them as I went, basically. So it's like, okay, what's like the first thing that I need to get a handle of? And the first thing I needed to get a handle of was like, how do I even compare these binds and then keep track of like which ones were matching which? So my idea was like, oh, make this match bind set thing where I have like, you know, the index for the process side, and then like, you know, a set of indices for the pattern side that it could match. So it's like, okay, great. I got this construction now, this match bind set, and but what does that do for me? Well, it like corresponds to all these different maps. So like, okay, I'll turn this into all of these different, like possible rearrangement maps essentially. So this is very much built in the way that the different iterations of my understanding of like how to do this stuff. And yeah, now it's all there and working, and I just haven't gone back and like optimized every little thing about it. But I will say like one thing that happens is like it will, so if I were to ask like, okay, do these two receives match one another? And they're both, patterns to some extent, and that's okay. I can still ask the question like, do they match one another? And the first thing that it's going to do is say like, well, do they have the same type of binds? Like, is it, if it's linear binds, then like whatever binds are over here, they better be linear. If they're, repeating or, peak binds, like out of the question already. The other thing it's going to ask is like, well, okay, if they're both linear binds, well then like, are there the same number of them? Before I even go to like start computing this match bind set, because I'm going to have some kind of weird nonsense that happens if they don't have the same number. So it does a check for the number as well. So it checks the type, it checks the number, and then it goes to compute this match bind set for these receives. So that's what this part of the code is doing. And then like these three blocks are doing exactly the same thing, except in the one I'm saying like, oh, I have some linear binds, and this one I have some peak binds, and in this one I have some repeat binds, but they're identical essentially. So I definitely check to make sure the binds are correct types, like they're all linear or they're all peaks or whatever, and then check how many of them there are. So like rule out all of the ridiculously obvious cases where they don't match, and then before I compute this match bind set. But it sounds like there may be a way to do like a more dynamic checking of like, okay, I saw that the 0th one matched these, like maybe I already know that this is not possible. But currently the implementation is like generate this entire match bind set and then check that it's okay. And so the way that is working at least is, so then I pass it to this function I call match if, and that's kind of checks some preconditions before it checks like that they actually match. We don't need to talk about all of this stuff, but basically what match if is going to do is it's going to take the match bind set, so that's like this first argument here, and then it's going to do these two checks on it, and that's called check match bind set basically, and check match bind set plus. Super creative names, but doesn't really matter. It's what they do that matters. So what it's going to do, so what check MBS does is it first goes and checks that each one of these guys, each one of the process side binds actually has something over here to match with, right? So like this one would fail on that check because it has an empty set here basically. So it'll traverse this thing and say like, okay, is the set over here empty set or something else? If it's the empty set, like automatic fail. If it's not the empty set, then okay, it lives to see another check basically. And then what this check plus does, this is kind of like the second check that I do, after I just have this match bind set thing, is so then it's going to take all of the stuff that's in on the process side of this match bind set construction. It's going to union all of those sets together. This is the only way I can think to do this. It'll union all of the sets together and make sure that all of the pattern binds were actually matched by something, right? So like, so here's one case where that first check would fail, is because I have an empty set here. But you can think of a silly case where the second one would pass, and maybe it's clear that there is no match. So like, let's just modify this a little bit. Like maybe this is empty. Maybe this one is actually like appear, and I'm saying like the 0th bind could match with any of them, and you know, no other bind matches with anything basically. But point being is like this one certainly won't check that pass that first check. It would actually pass the second check that I do, this you know, check MVS plus.